Hello, this is Peter from OneCNC UK, and in this video we're going to focus on the differences between OneCNC XR7 Advantage to OneCNC XR7 Mill Professional. It is a question we get asked regularly, so this is a short video to go through the differences between the two powerful products. Here we have both versions on the screen. On the left we have Mill Advantage, and on the right we have Mill Professional. And straight away you'll notice the difference on the screen. OneCNC Mill Professional has a full suite of surface and solid modeling options, and we'll have a look at how simple these are to use when we've been through the differences in the model toolpaths. So I'll open up the model toolpaths in Mill Advantage and also in Professional, and you'll see there's one extra toolpath in Mill Professional. But the main difference is the technology built into the Z-level roughing option. In Mill Professional, Z-level roughing 3D toolpaths has high-speed open and high-speed closed options. In Advantage, you have high-speed open and high-speed closed when doing mill pocketing in 2.5D. As I say, in Professional, as well as 2.5D, we have it in 3D toolpaths, and it makes your toolpath far easier to program and much more efficient. So we'll go ahead and see the differences. So I'm just going to minimize Mill Advantage and make my Professional screen a bit bigger, just so we can see exactly what's going on. Okay, so let's edit this toolpath. Now this has been programmed as it would be in Advantage. So we've selected the tool and the speeds and feeds. We're quite happy with the clearances. Z-level roughing. In Advantage, you only have traditional. We'll have a look and see what difference high speed open and high speed close will make when we finish this toolpath. Because I'm starting outside the boundary, I'm going to plunge, I'm going to spiral inwards and climb mill. Quite happy with my depths of cut and step over. Quite happy with finding flat areas. We're working to a pick boundary. We're starting outside, Z top, Z bottom, and finished. And there is our Advantage toolpath. So let's simulate this through. You'll notice as well in Professional we have the option of simulation to a stock model, and we'll see that when we transfer this toolpath to a Professional one. So at the moment we're picking a boundary, top of the job, bottom of the job, and straight away you'll see, even though I've told this tool to start outside of the boundary, it's plunged into the center. It's working its way around the profile, doing a bit of fresh air cutting. So before we go any further, we would really have to change our feed in to a helical entry. Obviously this is going to add cycle time onto your program, but we will change to ramp helix, push through the form, and we'll go back into simulation. Okay, so now we're doing a nice safe entry, helical. Tool again is doing full channel cutting at this point and some fresh air around the profile that doesn't need to be done, again wasting some cycle time. So we'll just carry on and push through the first level of this toolpath. It's now radially profiling in at its 50% step over. Let's see the difference when we do this the Professional way. So we've got exactly the same information. I'm just going to duplicate that toolpath. I'll just drop it into another toolpath group and we'll go into edit. Okay, we're going to leave everything exactly the same, speed and fees wise, clearances, but this time we're going to use our high speed open toolpath because I want to start outside the boundary. And you'll also notice you get the option of rest machining. Just like you do when you're doing 2.5D toolpath pocket machining, you can go with large tools to get rid of the stock as quick as possible, and then you can compare a small tool back to the larger tool's toolpath, and that will ignore everything that the large tool's just done. It's a much more efficient way of removing stock. Because I'm starting outside the boundary, quite happy plunging. Just going to change the depth of cut so it's the same as on the Advantage. Not really too worried about reducing steps at the moment. We're working with a pick boundary. We're staying outside the boundary, and we can select finished. And there is our high speed toolpath. As I said in the simulation for Advantage, you either work 2D or you pick a boundary. OneCNC Mill Professional has the option of simulating to stock, and inside of the stock layer you can have your entire setup, your vise, your jaws, your billet, your side stops, any straps that you have holding the component down. You are then collision checking your entire setup on the machine before it actually goes into production. So let's go ahead and simulate. I'm just going to turn off the stock layer. It doesn't need to be open. I'm going to simulate rest. I'm now simulating to a stock model, and we'll just zoom in and restart. And straight away you can see the tool is plunging into fresh air. It's then radially moving in towards the profile. You'll know there are no fresh air cuts anywhere. Mill Professional knows the size of the boundary is the same size as the billet, so there will be no fresh air cutting around the part. And we'll just accelerate this simulation through. As I said, you're fully collision checking your entire setup of the machine in Professional. So let's see what difference this makes to the cycle times. We'll do the Advantage one first. It's going to go into post operation, select job sheet. As you can see, that part's taking approximately 57 minutes. Let's do the same with the Professional. As you saw, I didn't change the speeds and feeds at all. I left it exactly the same. Job sheet. This one is taking just over 38 minutes. So you're saving approximately 20 minutes on this component. Quite a small component. You imagine the savings you could make on larger ones. It also utilizes your tools a lot better. You're not going into full area contact on the tool. You've permanently got 20, 30, 40% radial engagement, whatever you program. And you've got a 30% saving straight away. So obviously increasing the capacity of your machine. Just going back to Advantage for a minute. Z-level finishing wouldn't be any different to complete these tapered bosses at the top, but we would need to machine this flat area down at the bottom. In Advantage, you would need to have to extract the edges from around that profile. You would then need to extend them by at least half the diameter of the cutter. You would then need to go into your stock tool paths, high speed pocketing, select the boundary. I'm quite happy with the 16mm mill. Depths, traditional, plunge, step overs, and finished. So you've got to create yet another boundary to machine the flat area. Let's do it the Professional way. So we're going to go into model tools. Let me just turn off that pocket boundary that we created for Advantage. We're going to use flat area machining. I'm going to use the same diameter tool. Just going to push through this form for the clearances. We're going to use high speed open. I'm going to start with plunging. Quite happy with the step over distance. Don't want to leave anything on the sides. We're working to a pick boundary. We're staying outside the boundary, And I'm just going to pick the original billet size boundary that we use for roughing and right click. And as you can see, very little work involved. It will machine multiple flat areas. If I'd have asked it to start at 0 and finish at -50, it would have machined the areas on the top face as well. Let me go ahead and show you. If I just go back into edit, we'll change the height settings for the toolpath. This one will start looking above the top of the job, so we'll say 0.5 of a mil and finish. And no, we don't want to recalculate the toolpath. So as you can see, multiple flat areas using a single boundary, much more efficient, much more time saving. Again, increasing the capacity of your machine tool. So let's have a look at our modeling operations. We've been given a drawing from our customer. Obviously this drawing has tapers on it, so we need a solid model to manufacture to, whether it be in Advantage or Professional. But you cannot create these solid models in Advantage. So we'll have a look at how simple these functions are with inside Mill Professional. So I'm going to turn off the layers that I don't want, just leaving me with the drawing. And I'm just going to copy this one section onto its own layer. I don't like altering the customer drawings, so I'm just going to select that area of the drawing, copy to clipboard, paste some clipboard, and I'm just going to drop it onto a layer called model. And then we can turn the original drawing off. Okay, so I'll just move this onto a datum. So I'm just going to go into move, grab hold of the center of the ball, and drop it onto center. Okay, so the first thing we need to do is give this profile depth. I've got the drawing open on another screen at the moment, but as I say, we can always open up the original drawing and review back to it. But I've got a drawing on another screen, so I don't have to keep opening that up. So the first thing we want to do is give this profile some depth. So we're going to go into our extrude options. We're going to extrude a boss. You simply left click on the profile. You can then drag that profile down. Now I don't want tapers on this, so we're 0 and the height is -25.4. And then we just left click to accept. So the tapered up stands and the pocket detail are the same both sides of this model. So what I'm going to do is move the plane down onto the base of the model. I'm then going to select the profiles that I want to project down onto the base. I'm going to go into Smart Projection. I'm projecting to a plane. I want to keep the original, so I'm making a copy and select OK. So we've now got the geometry required on both sides of the model, so I can start creating these upstands. So we're going to use Extrude a Boss again. We're going to select the profile. We've got a taper height of 15 mil. We're going to give it the height of the boss, which is 19.05. Then we just left click on the screen. Now you'll notice it retains this information. So when I left click on the next boss, I just have to left click twice to accept all the information. So very quickly, we've now created our 4 tapered bosses. And I want to cut this pocket in. So we're going to use Extrude a Cut. We're going to give it a depth of -6.35. And again, we just simply select the geometry and left click. And I could do exactly the same on the other side. Select the geometry and left click. Very quick, very simple. So this is coming along quite nicely. So let's cut the holes going through the part. So again, I'm going to go for Extrude a Cut. I'm going to select the geometry. And I'm not going to give it a depth this time. I'm just going to literally drag the hole through and left click. As you saw on the main drawing, it had a fillet radius typical of 3.175. So we're now going to go and use our model tools. We're going to fillet. We're going to give it a standard fillet of 3.175. And what we're going to do now is digitize this model. We're not picking up on the geometry here, we're actually picking up on the intersections. You can select as many as you like. So I'm going to do around all the bosses and around the pockets. So I'll just turn it over, make life a bit easier, and we can left click on all of those profiles. There's radiuses on the top of these pyramids as well. So we'll grab hold of these top of these pyramids and right click. Okay, I did forget one thing. We have radiuses going around the main profile as well. So back into fillet, select the outside profile, top and bottom, and right click. So all that's left really to do now are the chamfers. So we'll just go into our filleting options again. We're going to use chamfer. It's got a common chamfer size of 0.5, and then we can just digitize the top of the bores and the pockets. Very quick, very simple, very powerful tool. And within a matter of minutes, we have a solid model that we can cut to. Another good use for surfaces and models is to control your toolpath. I probably wouldn't want the end mill I'm going to rough out with diving into this hole or this pocket. So what we can do is put surfaces on them. To create surfaces, we just go into extract an edge. We select the pockets and the holes that we don't want the tool to go into. No, I know the tool wouldn't go into that. It's too big, the one I'm going to use, but we'll digitize it anyway. We'll go back into our surface options. We'll use surface and curves. We'll digitize the top areas first of all, as they're on the same level. And we'll do exactly the same on the pocket area. So very quickly, I've created 3 blanking surfaces, caps if you like, just to control the toolpath to ensure it doesn't go into that particular area. So let's put a quick toolpath around there so I can show you another big advantage with Mill Professional. So we'll just go into line. I'm just going to draw a very approximate billet size just so we can cut to it. That looks about okay. We're going back into our model tools. We're going to use Z level rough. I'm just going to change the tool to something slightly larger. We'll go with that 20mm one. Quite happy with the speeds and feeds. Quite happy with my clearance form. We're using high speed open again. I'm going to plunge because I'm starting outside the billet. Quite happy with, let's say, 25% radial. Let's say depth of cut, we're going to go 25mm. We want to leave stock on the sides, so let's just say 0.2. We want to leave the same amount of stock on the bottom. And now you'll see this option called reducing steps. Well, reducing steps is an option in Mill Professional. Obviously, when you're taking 25mm depths of cut, the surface finish that it's going to leave going down tapered areas or surfaces, curved surfaces, is going to leave you an awful surface finish. In Mill Professional, you have this option called reducing steps. And what Mill Professional will do once it reaches the island that it creates when it takes a cross section, starting from the bottom of the toolpath, working its way back up to the top, it puts these reducing steps in. A semi-finished toolpath, if you like, with the roughing tool. So just for simulation purposes, let's say we're going to go with a 2mm step back. We work into a pick boundary. Top of the job, let's say I've got some material to come off the top face as well. So let's start it at 1mm. And bottom of the job, we just want to go past that flange. Let's go minus 45 and select finish. Select the boundary and right click to finish. So there is our Z level roughing toolpath. So let's just simulate it through. Okay, we're not working to a stock model on this one. I'm just using the boundary. Top of the job 1 mil, bottom of the job, let's say minus 60. We're going to select the boundary for simulation and right click. And as you can see as before, if I just slow it down, it starts outside the billet, profiles its way in towards the center at a constant 25-30% step over. No fresh air cutting again, as you can see, because it knows the size of the billet. And we'll just speed this up a bit. There we go. And you'll see now this step back option. It's now reached the area of the model that's tapered. So working from the base of that toolpath back up to the top, it's just going to clear that little bit of stock away from the middle. It's now going to start doing its reducing steps from the base of that taper all the way back to the top. So you get the advantage of being able to get rid of the stock as quick as possible, plus you get a semi-finished profile. So a very quick and a very efficient feature for roughing and semi-finishing your part. I hope this has been helpful. If you have any questions, please call us at OneCNC UK and we'd be happy to help. Thank you for watching. Bye-bye.